In this video, we're going to be finding the volume of a pyramid and a cone. And we're going to find that the volume is actually pretty similar. The formula to find the volume, similar to our other shapes in the previous video, we're going to do the area of the base. We're going to multiply it by the height of our figure. But for pyramids and cones, we're going to divide by 3. And the reason behind that has to do with a ratio comparing a couple of different things in our figure, and I may get into that in a different video, but for this video I'm going to keep it simple. If you can find the base area and you're given the height, all you have to do is multiply those two things together and divide by 3, or multiply by 1/3, that would be the same thing. And you get the volume of a pyramid or a cone. Let's do a pyramid first. In most cases, you're going to start off finding the volume of pretty basic pyramids. They'll give you all the dimensions that make it really nice and easy. Here's a height. It's perpendicular to our base. We'll call it 12 inches. Alright, so we got everything we need. We got our length or base and width or height of our base here. We can find the area of the base pretty easily. 4 times 10 would give us that. And we're given the height, so base area times height. If we divide that by 3, we get our volume. We can always simplify first. If you do one of these and simplify first, it makes our multiplication a little bit easier. If I do 12 divided by 3, then all I have to do is multiply 40 times that result, which would be 4. So 40 times 4 is a bit easier. And again, we could simplify this by just multiplying 4 times 4 and putting a 0 on the end. So 4 times 4 is 16. And we put a 0 in for 40 times 4. So our volume ends up being 160 inches, and we're still using cubic units, so inches cubed would be our units. So it's a tiny little pyramid there. But again, it's pretty basic formula. Base area times height divided by 3. Now, it gets a little bit more complicated when they don't give you all of your essential dimensions there. Some cases, they may give you the base. Let's make this a slightly bigger pyramid. We'll use feet as our units. And we don't know the height. And now we're asked to find the volume. Let's say that they give us something that will make it a little bit easier here. This is called a slant height. It's the height of the slanted face there, which is not the true height of our pyramid, but it's going to help us get there. We'll say that they tell us that that's 13 feet. Well, if we use that information, we can actually find the height if we draw a triangle here in the middle of our pyramid. And make sure it's a right triangle. And really what we just drew is a radius of our square down there, or the radius of the base. And if our radius is actually perpendicular to the outside edge, it's a special type of radius called an apothem. It's not too important at the moment. Just know that that will always be half, or right in the middle there, of your outside edge. So half of 24 would give us a little base of 12 for that triangle. And we could separate this just to make it a little easier to look at. Here's our slant height of 13. And now our base measuring 12. So we're missing that side of a right triangle. And if we know that information, hopefully you can jump to knowing that this is a special 5, 12, 13 right triangle. Anytime you're given dimensions of 12 as a leg and 13 as a hypotenuse, and it's a right triangle, you know your missing leg has to be 5. But you could also use Pythagorean theorem if you wanted to figure that out. You could say x squared, there's a squared, it's 12 squared, we'll say that's our b. It has to equal our hypotenuse, or c squared. And then we would eventually figure out that x had to be 5 anyways. So now we know one more crucial dimension, our height, 5. Now that we know the height, we can find the area of the base and multiply by the height. And divide by 3, of course. So the dimensions of our base here are 24 and 8. And we multiply the base area by the height and divide by 3. Is there any simplifying we could do first before we have to multiply this all out? Well, usually simplifying the biggest number makes it more simple. So 24 divided by 3, we could do that. That's 8. So now we have 8 times 8, or 8 squared, times 5. We could do the bigger numbers first, or we could multiply the smaller numbers first, which makes it a little easier. 8 times 5 is 40. And then 40 times 8, we could do in our head, it's just 8 times 4 with a 0 on the end. So there you can see an example of how simplifying helps you do problems in your head a little bit better, and in some cases it's a little faster than doing it on the calculator. So there's our volume, 320, and our units were feet, so we got 320 cubed feet, and that is the volume of that pyramid. Alright, so there's volume of pyramid, and that formula is actually the exact same for our cone shapes. Cones are used a lot, problems in calculus and science class, so it's always good to know the volume of a cone. If you can see that the base shape is the circle of the cone, that's kind of what gives it its circular shape. So if you need to write that as a note, base is a circle, so we would find the area of a circle for the base area. Say that on our first example we know that the radius is 9 yards. And they're nice to us and they give us the height of 8 yards. So we'd find the base area and multiply that by our height and divide by 3. So the area of the circle is the base, r squared times pi, which would be 9 squared times pi. 9 times 9 is 81. We'll keep it in pi form for now. You're going to multiply by the height, which is 8, and we're going to divide by 3. We can multiply the top in our heads. 80 times 8 is 640. Well, and then 1 times 8 is 8, so 648 pi divided by 3. We could have also simplified a little bit, make it a little easier on ourselves. 81 divided by 3, well that's 27. And 27 times 8 times pi would give us our volume still. 20 times 8 is 160. And 7 times 8 is 56, so put them together and we get 216 with pi attached. And our units were yards, so we got cubic yards, 216 cubic yards for the volume of that cone. So there's an example of a volume of a cone. Let's see how we could complicate that. We might do something like give you the diameter instead of the radius. Let's say we get a diameter of 18 feet. And instead of giving you the height, they give you the slant height instead. Let's say they give us 15 feet. Well, again, we could find our height by using triangles. So if we draw a right triangle here, and we split our diameter in half, find the radius, half the diameter, half of 18 would be 9. So we know that little segment of our triangle, or leg of our triangle, is 9, and we're missing our height here. Well, one way we could do it is by knowing that we are looking at a 3, 4, 5 in a different scale factor, where it turns out that everything is multiplied by 3. So we're given that, we're given this, and we're missing this guy. Well, 3 times 3 is 9, 5 times 3 is 15, so 4 times 3 would mean that we're missing a length or leg with 12 as its length. We could also do Pythagorean theorem. If we did 9 squared plus what we're missing, x squared equals our hypotenuse, or c squared, then you would eventually find out that x is the square root of 225. That's 15 squared minus 81. And just to hurry up here, we would eventually get 12. This would be 144. Square root of 144 would be 12. So do you see how knowing your special right triangle saves you a lot of time? Okay, so we got our height. We find the area of our base, that's the area of the circle. R squared is 9 squared times pi. And we finally got our height. Divide by 3 because we're talking about a cone. 9 squared times pi again is 81 pi times our height of 12 divided by 3. Simplifying this will help. 81 divided by 3 is 27. We still got to multiply by 12 and we still got pi. So we can't really simplify any more than this. We got to just go for it. We could do 27 times 10, that's 270, plus 27 times 2, that's 54, and we still got pi on the outside. 270 plus 54 is 324, we still got pi, and if we actually multiply that out, 324 times 3.14, we get approximately 1017. 0.4-ish or 3.6 or whatever. It's close enough. Pay attention to directions on what they want you to do. Either round to the nearest tenth or hundredth or whole number. So the volume is approximately 1017 cubic feet. That was our unit. And that was volume of a cube. So good luck either finding the volume of a cube or the volume of a pyramid using that formula. Just base area times height divided by 3. Good luck.